Just to make it simple, we plant a special tree that is right for the type of contaminant we're trying to clean up. We inoculate them with microbes. So it's a site that has hydrocarbons or like oil and gas products. We would use hydrocarbon-specific degraders that are just natural endophytes, just bacteria that already exists in nature. But we've identified them and we put it into the tree, and the tree becomes sort of a super degrader.
Hello and welcome to the Conscious Design Podcast. I'm your host, Ian Peterman, and I help turn product ideas into sustainable seven-figure businesses. Join me for another episode where sustainability meets innovation and business savvy. Today, I'm really excited to have Renee Murphy. She's a sustainability keynote speaker, educator, international TEDx speaker, which her talk was on trees and microbes cleaning toxic sites, which is really cool. And right now, she's an environmental scientist and director of business development in Intrinsics Environmental, where they're combining nature with engineered solutions for sustainable environmental remediation. Welcome to the show.
Thank you so much, Ian. Thanks for having me.
Yeah, I am really excited to dive into this, as remediation and cleaning soil is a big problem to tackle. And we definitely need some good options to be able to do that. But first, let's talk a little bit about how did you get into this industry? What got you into this environmental sustainability space?
Well, Ian, I'll tell you, I spent most of my life in the fashion industry, actually. I had my own business and was really living the dream that young girls dream of, going back and forth from LA to New York every month. I had gotten to a point to where really I was at the top of my industry. But for years, I had this anxiety that was creeping up every day, and something about the way I was living my life and what my career was focused on, which is really, overconsumption and selling this idea of perfection. And, at the time I had a daughter that was growing up in her teen years, and I could see how much she was watching me and mimicking me, and started to see things that were unsettling, but why was I so unsettled? And I had started getting into hiking and walking out in nature. And the strange thing happened when I was outside. I would feel at peace. All of those ruminating thoughts would go away. And I just felt so inspired by what was going on with the ecology of every location that I was at, and started to become more and more obsessed with nature and started having a really hard time going to work every day, because it just seemed like it was no longer in alignment with me. And I made the decision to walk away from all of that in my mid-40s, which is a bit of a scary leap to make. But I was inspired by a trip in Houston where I had gone to NASA on just a tourist trip. Never really into space and all of that. But I thought, I'm here, let's check it out. And one of the exhibits talked about how scientists were exploring how to grow plants on Mars. But because the soil is toxic to humans, how would this happen? And then they went on to explain that plants on Earth have this ability to clean soil and water and the air through what was called phytoremediation. And that's just plants cleaning. That's simple. And I thought, well, if we could do this technology and we're exploring this on Mars, why aren't we doing this right here on Earth? And that sent me down the rabbit hole that made me make the decision and the career pivot to become a scientist. So I went to school, got my master's in plant science, and I was off to the races with this degree focused on native plant restoration, working as a sales director at a native plant nursery and doing some collaborative research, trying to grow trees in a very toxic area known as the Salton Sea in Southern California.
Yep, familiar.
And it's, salt impacted, drought impacted. In addition, it's highly toxic. And how do we restore areas like that? Because this is the problem all over the world, is that we have these areas that are degraded. And what do we do with them now? Can we grow on them anymore? No, not because we farmed on them so poorly in the past. How do we go on to regenerate land? And how do we clean land in ways that doesn't require us just digging and hauling it? Because that is one of the big methods of doing contamination cleanup is digging it up and just moving it to a toxic dump site, which are we really doing?
That's the same problem, just a new spot.
Right. We've just moved it. I mean, they do this in Alaska. They barge the soil to Washington or Arizona. It's really, as a newcomer to the industry, I was baffled. So when I was working on this restoration effort, someone I had known from my past decades ago saw a posting that I had done on social media about this work I was doing. And he reached out to me and said, hey, I used to work with NASA. This is the field that I'm in. Talk to me about your research. And within months, I ended up moving to the Bay Area, San Francisco area, and working for Intrinsics Environmental, working in phytoremediation. So we do just that. We can clean not just soils, our groundwater as well. So we work on cleaning groundwater and soil using specialized tree and plant species. And then we inoculate those tree and plant species with naturally occurring microbes that have just evolved to be very specific to breaking down certain contaminants. So just to make it simple, we plant a special tree that is right for the type of contaminant we're trying to clean up. We choose the right plant based on the depth of the roots and the depth of where that contamination might be and what our objectives are, what the client is looking at, the speed of which they're trying to clean it up. A lot of this, we have environmental regulators involved in directing how the cleanup is being done, which is why it's terrifying that there's so many rollbacks in this, what was the new great deal that was just passed. I don't know if I've got the exact name, but within that, there's all these environmental rollbacks for regulators, which is scary to me because that is the reason that cleanup is being done at all, right? So we plant these tree species, we inoculate them with microbes. So it's a site that has hydrocarbons or like oil and gas products. We would use hydrocarbon-specific degraders that are just natural endophytes, just bacteria that already exist in nature. But we've identified them and we put it into the tree, and the tree becomes sort of a super degrader. In phytoremediation, it's been used for decades, but one of the issues that we'd come across is that when you'd plant the trees, the area was too toxic. And so the trees would get phytotoxicity and they would die. So now we are able to plant trees in very high contamination. We call it those source areas. Plant the trees, inoculate them, and the trees thrive because they're able to manage that particular contaminant. So kind of like if I gave you amazing probiotics and built up your gut bacteria, you would get sick less. You would be stronger overall, your whole system. So it's incredible technology, but it's what's considered a new emerging technology. So you could imagine, like any industry, it's difficult. We have to consistently educate people on this new technology and that it's not phytoremediation of the past, because some people may have tried it in the past and it wasn't as successful as they would have liked. But it is the only real green, sustainable technology. And if you could imagine, a lot of these locations are located in areas that are underserved communities. They tend to be you never go into a rich area and see, there wasn't a factory in a rich area, right? So they're always localized more in these underserved communities. But when we leave or the remediation is done, the community is left with a forest of trees versus gray infrastructure.
Right. That's amazing. Yeah, this has been such a fascinating, and I'm sure there's like some of this stuff is really old, but I've seen articles on, there's a new mushroom that's been discovered that it breaks down this kind of plastic,
Yes.
or that breaks down oil, or a moss. Like these just little plants, they're like, oh, there's a plant that eats that? That's terrible toxin. We'd die if we had that much.
You could see how incredible this is if we could learn to harness the powers of nature to do this work for us. They already have the capabilities. It's just we have to understand it as scientists and then be able to take it out of academia and move it into commercial, which is what we've done with this technology. The research was done by the University of Washington for 3 decades by Dr. Sharon Doty.
So this is old. I mean, this is really old.
She's been characterizing these microbes for decades, and she's been published in journals many, many times. And so we, along with Dr. Freeman, who founded our company, has commercialized that. And our very first project was with NASA in Mountain View and the EPA. And we're able to show that it did, in fact, work we specifically worked on chlorinated solvents there. But so we have microbes that work on chlorinated solvents, microbes that work on oil and gas, PCBs, ammunitions, and we're now optimizing our ability to uptake metals because plants do handle inorganic contaminants differently. The first set of microbes actually break the contaminants down into non-toxic substances. When we're talking about inorganic contaminants, the plants do take it up into their biomass. So we do handle that a little differently, but you can see how important it is to have experts in this field understanding how the plants will naturally behave when you give it a certain contaminant and how would we systemize that in order to remove it. So it's really cool.
I love that. Is there... Because I'm just curious, so it's actually breaking it down. So that means that the plant itself is not really impacted. Like it doesn't become a toxic. It's not like a sponge where it's the toxicity is now in your trunk and then you have a toxic trunk. It's actually, if I'm understanding, breaking it down. I would say that is everybody's fear is like, okay, so now you're just leaving us with toxic trees. Well, Well, no. So, yeah, that is actually not happening. So that symbiotic relationship between the microbes and the plant. So the microbes want to live inside the plant. So endophyte, inside the plant. They want to live inside the plant, but what they do is they're going to metabolize. Everything has to metabolize something, and they metabolize these different contaminants. So it's just being broken down into simpler byproducts that are not toxic. And it's being broken down within the soil, within the roots, within the tree trunk, and some volatilizes out through the leaves. And we do phytoforensics. We do tree core analyses, leaf tissue analyses, and specifically look for the contaminant to make sure that it is not stacking up in the tree. Because if that's happening, something's not right with our system. So we look for stress in the trees. We want strong, healthy trees, and that guides us. And then again, we're looking at our mediums, whether it's water or whether it's the soil, and we're able to see whether we are degrading these different contaminants. Amazing. And you mentioned earlier something about being able to, part of your selection based on what plant you start with is also how deep into the soil. And you mentioned groundwater, which can be a little ways down.
Yeah, it sure can. But
it is contaminated. Like the contaminants will soak all the way down. So it's one question, like how deep can you go? What are you able to pull up out of this? Yeah.
That's a great question. So I would say the species that we tend to use the most, because it is an exceptional phytoremediation plant, and that is the poplar tree. It's called a phreatophyte, which just means that it's super thirsty. And if we're trying to clean up groundwater, we're trying to get the tree to drink up the water and transpire, right? So when it drinks it up, that's when the degradation is occurring. So the more water we take up, the more breakdown is occurring, which is confusing to people when they say, well, we want a native species, or, especially in California, we want a native species, something that's drought tolerant. Well, a drought tolerant tree is not taking water up quickly. So you see how we have to match. If we're trying to get a restoration effort, we're just getting a tree that can handle the contaminant, but the goal isn't to do like a groundwater cleanup. Okay, then we can look at natives, but we have to use a species that is thirsty. Willows are another great one. So we would look at the groundwater depth and determine poplars can go down to, say, 30 feet with their root systems. So that gives us a lot there. Willows, around, I'd say 10 feet average. So we are looking at where the contamination is. Is it up in the soil? Are we looking for trees that will spread their roots just this way? Or are we wanting ones that will, get a semi-tap root and just go seek that groundwater? Additionally, we have hybrid poplars that are like salt and boron tolerant. So if we're moving into a site that we know is high in boron and high in salt, we would use those trees because that's just like an added benefit. These trees are already going to be tolerant up to certain levels. So you can see it's a lot of figuring out what is the best system, what are we trying to tackle, and the speed at which we need to do the cleanup. So depending on the budget of the client and depending on what the regulator is asking, that would determine how many trees we put in, right? So, and we can put them pretty close together. We're talking like up to 5 feet, really tight spacing. Like we have done what we call functional landscaping, which I love the idea of. So a lot of redevelopment is happening on brownfield properties. And that's just properties that have had something there industrially and are suspected of having some contamination. And so these lands might be bought by a developer at a reduced price, but they do incur the liability of the legacy contamination. They didn't do the contamination, but it's there and they have to deal with it.
And they got to deal with it.
Right. So if you could imagine, you could develop a property at the same time, put our trees in. So you're cleaning up and developing all at the same time. And while that property is then being used for the purpose, it's still being remediated. So at no point are you going in and just scooping everything out, removing it, and then redeveloping it. You could do it at the same time using this functional landscaping. And again, this functional landscaping is being used all over California, and it's really kind of amazing because you're hitting a couple of things. You can plant trees throughout a parking lot. So you're kind of battling that heat island effect because you're putting in very fast growing trees that put on a lot of leaves very quickly, get very tall.
I live in Arizona. I know all about this.
Right? Like Arizona is a place.
Everywhere is insane.
They're not planting enough trees in Arizona. Through their parking lots, everyone fights over those couple of spots that have that trees.
The 2 trees.
The cooling effect is real. So you could densely plant trees through a parking lot and they won't disrupt the infrastructure because of the way they like to grow straight down.
Picking ones that don't spread out.
Right. So you have to be very careful, like what's your infrastructure and understanding all of that. But again, you'd be doing that with any remediation. You'd have to be very focused on what the existing infrastructure is and how your system will fit into that. So, you can do this type of functional landscaping, but additionally to that, we've now moved into the restoration field where maybe a restoration company has tried to get establishment and can't because again, whatever's suspected in that soil is making it very difficult to establish their restoration efforts. So we can go in and plant native species. Now, this is where planting natives is great because we're not concerned about the speed at which they grow, but we are concerned about can they survive the first couple years? And so the endophytes give them, again, that boost to tolerate stress. And we can get establishment even in like reforestation efforts. Establishment rates are pretty low. So if we can increase that by just giving this microbial boost, you can see how many really great applications there are to this technology.
How? Because one of the things that I think of, and you probably have had to answer this question, when you think of like a tree growing, you're like, it's going to take 20 years. But obviously you're working on remediation where you're like, no, we don't want to take 20 years to do that. So I'm assuming that the lifespan of the tree is not it can remediate something faster than 20 years, basically.
Absolutely. And
I'm sure there's some slow ones, but.
And again, all of that, it depends on different variables we discussed earlier. But if we are trying to get a cleanup faster, we can start with much bigger trees. And now I want to explain to you what our trees look like when we install them. They're not what you would imagine. So you imagine a tree in a box holding its roots, right? So like
where you dig one little hole and you drop it in and you're done.
Or you buy a big tree and it's got like a tremendous box attached to it with its root systems and it's a lot of work to install. That is not what we do. It's just really cool. So we auger holes into the ground using like a skid steer. They're going to drill holes into the ground. We put amendments into the hole, very specific to what we're dealing with and what, depending on the conditions of the site. And then we put in what is called a pole or a tree cutting. So if you could imagine, it just looks like we're taking a branch from a tree. No buds, no roots. It's just like a stick. It was I did an installation one time and they had opened up the big gates for the construction, like the construction gates, because they thought I was coming in with a huge truck full of giant boxed trees. And I was holding all the trees under my arm because they're just cuttings. So if you can imagine, I've got 100 trees under one arm 6-foot cuttings. And they're like, where are the trees? I'm like, they're right here. Where are the trees? They're right here. So we put them into the ground this spring with propagation hormone and our endophytes and the proper amendments. You'll come back 3 weeks later. You have a tree with leaves. It's starting to form a root system. In about a year, it's getting to the point where the roots have reached generally where we're looking to get. And that degradation starts to happen. So recently, we just received a no further action, which is closing a site after 5 years on a contaminated sites with the trees, 0 tree mortality. And in 5 years, we closed the site. That's really pretty cool. And again, it depends on the contamination level and the size of the site. But we have had some really incredible quick turnarounds, getting the objectives met by the regulator.
And how does this, for all of our listeners there, how does this compare to like a standard? Like, what is a standard remediation process that you're replacing?
There are many different remediation methods, but I'll just name like a couple that come to mind. Like, so dig and haul is a big one. And a lot of times different methods are used in combination with one another. There is like soil vapor extraction systems where if you saw like the infrastructure involved, there's a big cage and then there's infrastructure, and that is working on removing soil vapor. Let me think of some of the other ones. You can go in and biologically treat certain source zone areas. So they are injecting bacteria and then feeding the bacteria, and breakdown is occurring again through bacteria, which is great. Ours is a little different in that the trees are doing the work so that you are left with that green space. But we do some biological work as well, or sometimes you might do them in combination with each other. It just depends on what needs to be done, or if they're looking to see like immediate work being done, then we might be brought in as a secondary step. We've put in what we call like a phyto barrier to protect maybe a river or a natural area on one side, but there's a refinery on the other.
Okay, I was going to ask about like kind of this proactive or ongoing thing where you know that you have a contaminant flow incoming.
I would love to see, I'm glad you said proactive, because that is unfortunately not being done right now. And I would love to see, especially some of these big corporations, look at, rather than being reactive, is can we be proactive? Like, we know certain things are going to happen. Can we put a barrier of trees around our site as a proactive measure? We know there's some natural space we want to protect. We're doing this proactively. So there are so many ways that if we wanted to, this could be one of the best ways to market your work. I mean, for me, if I worked for an oil company, I would want to be the leader in preventative measures. I mean, there's such this everybody has this bad taste in their mouth when we talk about oil and gas companies. Well, we all need our oil and gas. So it's not going away. But can we be the best company at being proactive and trying to eliminate any of this type of spills or leaks or leaving sites contaminated and then needing to clean it up? Like, can we just be more proactive in our thinking about that? Can we be proactive in the way that we're designing our cities? We already know that these, trees are cleaning the air, cooling the areas. Humans are healthier when we're closer to trees and parks. Can we incorporate more of this natural design and be very proactive with it versus after the fact? I think that's the problem. We have not used our creativity and our artistry, and I think that's inside everybody. And then we get into our careers and we get very jaded.
Yeah. Well, I mean, one of the first thought when you were mentioning, parking lots, I was forgetting the word there. There's, and not as much anymore, but like when I was a kid, there's a always oil stains, oil, and when you went to go rip up, and I'm sure it's the same case, when you go to rip up an asphalt parking lot, there's oil, like the oil seeps through. There's no way around it. So if you were to preemptively go, okay, well, we know we're going to have these kinds of things coming off a cart or highways or road, right? There's so many things we know it's going to happen. And if you're, my thought too is like, if you're already putting in green space of some kind, because a lot of places they do at least a little bit. If you were to like one step further and go, well, let's pick the plant species based on how it will handle toxins that we know are going to hit. Just those kinds of, it seems so simple.
There are species that also can be indicators of contamination, like a canary in the coal mine kind of thing.
Okay.
So, I was reading about different species that are indicators. So when they start getting sick, that's a signal.
Oh, interesting.
That's why the canaries were used in coal mines. When the canary died, they knew there was a vapor problem.
Right.
So
that is interesting.
Same kind of idea, but if you're thinking along the lines of that parking lot, our oceans, you don't surf in the oceans after a rain because all of the oil
Yes.
and contamination goes into the waterways. Why can't we design parking lots with understanding where that water flow would go into, and maybe it is directed into like a bioswale, and the plants
Right.
are planted there as that filtration system, rather than most water is taken up properties and then taken off the properties and then eventually ends up down at the ocean or into a processing center. Why doesn't the water get directed into a system that will actually treat it before it goes to its next location? These aren't complicated concepts. We just don't use them.
Hey, it's your host, Ian. I'm really glad you're enjoying this episode. I absolutely love highlighting amazing brands and founders for the awesome things they are doing. I've helped hundreds of entrepreneurs and businesses like yours turn their boldest ideas into powerful, purpose-driven brands. So if you're serious about building a brand people love, like our guests and clients do, and one that you're proud to stand behind, I invite you to dive a bit deeper with our book, Conscious Design. Inside, you'll discover the exact framework and steps we use to help entrepreneurs like you turn purpose into a powerful, impact-driven brand. A brand that stands out, attracts loyal customers, and drives sustainable growth with social and environmental responsibility woven into its DNA. Grab your copy today. You can find it on our website, consciousdesignhouse.com, or just find the link below in the show notes. Enjoy the rest of the episode, and don't forget to like, subscribe, and share.
Yes, we don't. And it makes me even think like, how could this, and I don't know if you've done this kind of thing, but how could this improve? Because like, if you look at our sewage treatment capacity, right? We have plants built for cities based on population numbers from the 80s and things like that, old, right? Obviously one of the biggest things that those systems do, obviously there's the waste matter, but also the toxins, all the stuff that gets washed in. I'm kind of one of the things thinking through this is like, could this type of plant be an assistant to that or add capacity to water treatment facilities?
So let me tell you about this project that I visited in Chicago, which you can think about waste treatment, but another one of our issues, there's waste, but there's also our landfills, right? So we visited this landfill, and there's the whole industry around leachate management. So you can imagine everything in a landfill turns into leachate, right? Which is basically like, your waste systems you're talking about. That leachate needs to go somewhere off-site for processing. So this site we visited by one of our partners, leachate management specialists, it was so incredible. So it was a giant city park. Everybody could use it for mountain biking. There's, a river running through it, but one particular area was gated off, and they had rows and rows and rows of poplar trees planted. They were taking the leachate, bringing it to the poplar trees and irrigating the poplar trees with it. And then the poplar trees were breaking it down. That was their water source. And they were breaking down the contaminants in the leachate. So that ultimately the project, they have to take the leachate off the property for processing. That costs money. That's part of what it costs to run that particular landfill. But the poplars were doing such a great job that much of what they had to take off site was very minimized. So now the trees are actually reducing the cost to the city because they are processing it rather than it needing to be taken off site. So I thought that was such a beautiful circular kind of system there. Like, if we could use that in so many more areas of life and the way our cities are run, we have to start thinking more circular versus linear,
Yes,
And,
absolutely.
we can beat the, plastic to death with how it's linear. And because of this, the thought wasn't in the beginning, how will this break down? How will this be recycled? How can we create this in a way that we can use its end products into something else that really can't be done, unfortunately? Like the recycled plastic is more toxic than the original plastic. And these end streams, they're still trying to figure out what to do with them. So this whole idea of like recycling plastic, it's not working. So we do have to think from the very beginning, the initial
We only
design.
recycle like 4% of plastic anyway.
Yeah.
Like we're not even actually recycling it.
Right. And there's so many different kinds of plastic, and we don't have the infrastructure to support that. And you could think about that with the same way with our, our electric vehicles. The idea is really great, right? So they're powered by your EV battery, but we aren't recycling those batteries. So
Right.
we're still linear. Any way you want to slice and dice it, we're still linear. There's no circularity there. We have no places to take the batteries. The batteries aren't getting recycled. The technology at a certain point, there's an end use to it. And then what do we do with that? So did we really improve transportation by making things EV? No, because we didn't think about the entire circularity portion, that there needed to be a way to manage each parts of the waste of EV vehicles. So that's my little sticking point about that. And not even to imagine, like, we have all these EV powered vehicles, but where do those minerals come from?
Strip mining, which is not exactly
And
great. And there's definitely the mining.
Mining in Africa.
I'm sure there's somebody somewhere who's doing mining who's thinking about this, but I would think that something like what you guys are doing would be an obvious, easy thing to plant around, like wherever you're mining. Like we're going to be mining stuff for a while. Like there's no.
We have to accept that we're doing it. So we have to figure out now how
do we do it better?
to do it the best way that we can, right? And our company has begun doing work within South Africa, and they've been very welcoming to this new technology. And so we've been doing a lot of business development in the area. And so that has been one of our targets, is all the mining there, all the destructive mining. But they now have regulations where mining companies also have to have an exit plan that includes revegetation, and which could be an incredible way to fit this technology into these revegetation efforts, because again, that soil is completely stripped. It's not really soil anymore, right?
No, it's rock bits, basically.
Right. So like, how can this technology be utilized there? And we have done some publications with the USGS where they found that the endophytes did help with establishment. So, that would be like the next great pilot project for us, is to do something in partnership with a mine to see, is this a technology that would be useful in this industry? So we're currently doing research in South Africa with this, and hopefully this will be a great place for us to go, considering what our future looks like.
Yeah, I love that idea. I feel like there's so much, right? And mines don't last forever. There is an exit point where it becomes not worth mining anymore. And so what do you do? The question of what do you do with that space? And when I was a kid, I actually lived near a small quarry that was done, and it just sat there. Like there was nothing to do. Eventually they backfilled it, probably with some remediated dirt. Who knows what they backfilled it? And then they put a parking lot on it in a small strip mall. And so spaces like that but it sat there for years and years and years doing nothing good for anybody. So I love the idea of this kind of thing where we can put something in, it has immediate use. It's green spaces. We all like green spaces. We love living near green space. Even just driving by green spaces is better than not. And it happens to pull out all these toxins, which is amazing. I wanted to add on the toxin side, one of the big ones that everyone is talking about, of course, is PFAS. Is that something that you guys have been able to go after with this?
PFAS is a big market, right? Everybody wants to know.
Huge. Everybody wants it.
So we do have research that we're doing right now, specifically with a collaborator. So there's definitely initial positive research so that plants can down PFAS. We have to be very careful because breaking it down into smaller chains, those are toxic too, right?
Yeah, there's a few layers before it.
We have to be really careful about it. So yes, we are doing the R&D right now on it. There's nothing commercially available yet, but there's also great research with a fungi as well. So
are you guys able to? Because I've seen some really cool research about fungi and it grows on trees. So
well, actually, so we can do. Remember, I said we could do multiple. You don't have to just do trees, right? So we could do remediation with the soil, right? So we can inoculate soil.
Right.
And then the trees might be dealing with groundwater specifically, and we're using fungi to work on the soil. And we have done that on
so
projects.
Being able to blend and put together this combination package, basically. That's amazing. So you're going after PFAS as a target area. What has been the most, and I feel like this probably applies to like farmland that's been overfarmed as well as industrial. Like what has been the most interesting kind of industry or category where you've put this into and had a site going with it?
Oh gosh, we have a lot of different sites and a lot of different types of contaminants, and we are working on salt-impacted farmlands as well. So that is an interesting area, but I'll tell you, just because it is sort of the part that's most important to me, I love that we're moving into restoration and the idea that, our biodiversity loss is incredible.
Oh, yeah,
We're losing plant and animal species faster than you could imagine. And that's largely due to, development, right? We're removing what's native to the area, planting whatever the big box store has or whatever's in fashion in the moment. And you can always see that. You can see certain decades of what was popular based on the age of the community, and their landscaping's all the same, right? And unfortunately, a lot of it shouldn't be in that particular area. Like throughout California, you can see the eucalyptus or the Brazilian pepper trees. Like or the tropical landscaping. It's so cringy to me, especially think about Arizona. So I know that they put in restrictions about not being able to put in lawns, which makes sense. You're in the desert.
Right, yeah.
Go to a city park with a lawn. You don't need it in your yard. So I'm all for that. But people said, okay, well, let me just put fake grass in. Plastic, what do you think that's volatilizing when it gets hot? So
it's not good. The heat is not good for that stuff.
It's volatilizing contaminants into the air around you. You have literally eliminated all biodiversity there by putting in plastic grass rather than plant life. And our insects and our birds need that plant life. And if you're removing it and then putting plastic grass in, like, why? Because you want to see green. If you move to the desert, embrace what's at the desert. Don't bring your tropical landscaping to California. It's not tropical. Like, learn about
Yeah.
what's in the area and embrace what's beautiful about the natural vegetation that is supposed to exist within that area. So why I really like working on the native sites is also trying to encourage customers to say, hey, look, yes, we can remediate this space and we can put trees in, but can we go one step further and start looking at how we can be more regenerative in our focus? It's
I
not
love
much
that.
more in your budget to like, let us put native plants throughout. Like, we could have trees doing what they do and let us revegetate with the native plants. So we are bringing back biodiversity and we're cleaning up. So there's a really nice restorative element. And we need to be thinking more like, how can we regenerate? How could we restore? And so this is one baby step towards that. And the poplar trees actually help, especially in hot, dry areas. The poplar trees, because they grow so quickly, they help sort of nurse up that successionary planting of the native plants.
Oh, okay.
The native plants tend to grow slower. And so they nurse that, and eventually those hybrid poplars will die out. And then the natives have restored the space. So a lot of cool ideas and way to just push remediation one step further in a better direction.
Have you, and there's obviously like commercial applications to all of this. Have you guys done much on like the residential side? Because I would think that there could be some good benefit, like you said, of people that are maybe they need to swap out their plastic grass for something real.
There actually have been, we get inquiries all the time from residential client individuals. Maybe they are right next to something that they believe is potentially contaminating to their property. And they're wanting to put in a line of trees or whatever it may be. And unfortunately, we are a business, and right now that's just not financially feasible to be working on a project that small, that we do need to have them be. So it would be better for like a developer to want to install this from the start.
Planning ahead.
But again, planning it. What if you are developing right next to a landfill?
Oh yeah, there's lots of developments right next to them.
Right. I mean,
with
couldn't
like
this
this
just
mini
be
buffer so you don't see it?
obligatory as part of the development is also doing this installation effort preventatively. But yeah, this has been an issue, with Alaska specifically is with the melting of snow, the infrastructure of like underground storage tanks and tanks for which they use to heat their homes break and leak quite frequently. And this is something that homeowners are affected by. And, these aren't people that have, substantial amounts of income to be able to pay for this type of cleanup work on their property. And unfortunately, there's not the funding available to help people as well. So, gosh, it would be incredible if there was community funding that could be used to help assist with this type of work, because there's lots of different methods, of which they could be working on cleaning up their own soil. But right now, it's just a difficult market to crack, right? Because it has to, you have to run a profit with a business. So until we could figure out the business model to that.
Well, that would be amazing if you guys figure out how to do that. There's so many people, that could definitely benefit. So
Right.
And I feel like it happens. Like you start in academia, now it's commercial. Like it takes some time to scale down these kinds of systems.
Who knows?
And you got to use it enough. You got to use it enough to figure out how to do it really efficiently.
Yeah.
To make it more cost effective.
Yeah. Who knows? It could be a completely different world in a couple of years. So
we'll see. We'll
hold
see.
out hope for that.
I will, absolutely. Well, this has been really amazing, Renee. I really appreciate you coming on and talking about all of this. Before we wrap, I just wanted to give you the opportunity to share anything that we might have skipped. They're like, I need to say. And then also, how can businesses reach out to you, find you, best way to connect with you guys if they have a project or just want to learn more?
Yeah, I think the one thing I just want to point out is that we are all individually responsible for our environment. And if, these thoughts should be going through your head every day. How can I be more sustainable? How can I be better to my environment in little ways? We start little, we get better at it, we get better at it. Then we start talking to our communities about how to be better at protecting the environment, how to be more sustainable. And then ultimately, we start voting with our dollars in showing corporations how we want our money to be spent on more sustainable products, on healthier food, on better environments. That's done with our votes and done with our dollar. So we are all personally responsible. I know people don't feel like they can make a difference, but you really can. It is the reason why I left my career. And in just a few years, I feel like I've been able to help spread this message internationally. So you can make a difference. So start there. I do speak to different corporations about sustainability. And if you have any interest in what Intrinsics Environmental does, just reach out to me on LinkedIn, Renee Murphy.
Perfect. And for everyone listening, watching, there will be show notes. So use those links. And yeah, thanks again for being on the show and sharing what you guys are doing. It's amazing. And I hope you keep figuring out new things you can get rid of more toxins.
Thank you so much.
And that wraps up another episode of the Conscious Design Podcast. If today's episode inspired you to bring your product idea to life and turn it into a sustainable 7-figure business, visit petermanfirm.com or click the link below. Your ideas have the power to change the world, and we're here to help make that happen. Thank you for joining us, and I'll see you on the next episode.